They gave us a letter known as engineering, and we were supposed to find the number of permutations for the letter. Now, how do you find the number of permutations? First, check how many letters are there in the word engineering. Okay, in the word engineering, there are 11 letters. So, which is nothing but 11 factorial. Okay, so 11 letters can be arranged in 11 factorial ways. So that is the first observation that we can do. Now apart from that, what is the next observation? Now in the word engineering, we have few of the letters which are repetitive. Now which are the letters repetitive? We have E, which is repeating 3 times. We have N, which is repeating 3 times. G is repeated twice, and I is repeated twice. Now when you have repetitions of the letters in a word, or any sort of object which is over and above repeated many times, then we will be calculating permutations of like things. Now like things are similar kind of letters in a word, or same brand of products in a list. All that will be considered. Now how do we find the permutation? N factorial divided by x factorial, y factorial, z factorial, and so on. If you have more numbers, so more alphabets can be added to that. Okay, so this was our first question. Now coming to the sub questions, the first sub question was begin with E and end with E. So they want how many number of words that we will be able to form where the words are beginning with E and they are ending with E. Okay, so that is what they wanted us to find. So the word E is fixed in the beginning and the word E is fixed in the end. Okay, two positions are fixed. Now apart from these two positions, how many other positions are left out? How do we analyze that? We'll have to take total number of words in engineering minus two positions which are fixed. So 11 minus 2 is equal to 9. So in between the first letter E and the last letter E, we will have 9 other words. Okay, we will have 9 other words. So if we have 9 other words, which means these 9 words can be arranged in 9 factorial ways. Okay, in 9 factorial ways. So that is the first numerator part. Now after that numerator part, now we'll have to check on the like things. Like things means things which belong to the same category, which are same or similar. Okay, now in the word engineering, we have N, which is repeated 3 times, G is repeated 2 times, and I is repeated 2 times. Now with this, what we'll be able to do? These 3, 2, 2, we are supposed to take the factorial of each of them, and we have to divide by the numerator, that is 9 factorial. Okay, how do we get to know that we have to use this formula only? It is very clear with the question. Now in the question, if you have repetitive things like this, then you will have to use this formula. So that was first sub question. Okay, now let's go to the next sub question. All 3 E's are together. Now in this, we are going to group the E's together. Now in the word engineering, we are going to keep all the E's in one place. So this will become one part, and this is known as one unit. Okay. All E's together are known as one unit. And then the rest of the letters, how many more letters are left out? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are left out. So 1 unit plus 8 other letters. I have totally 9 letters. Okay, or 9 units that I have to consider. I have 9 units that I have to consider. So 9 units, I can arrange them in 9 factorial ways. Now apart from E, which are the other letters which are repeated? N is repeated 3 times, G is repeated 2 times, I is repeated 2 times. Okay. So 9 factorial will be the numerator. And then 3 factorial, that is N, and 2 factorial, that is G, and 2 factorial, that is I. Okay, so this is the total permutation. So if 3 E's are considered to be arranged as only one way, then all the 3 letters are the same, because if you are taking 3 letters as one unit, they are arranged in E, E, E. Suppose next time I arrange second E, this E is coming first, and then E, and then E, but at the end of the day, all the 3 are E only. Okay, all the 3 are E only. So if I take this third E first and then write down E, 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 again in all the cases, only E is being grouped as one unit. So that is why we don't take extra 3 factorial for this E. Okay, we will only end up with 9 factorial by 3 factorial for N, 2 factorial for G, and 2 factorial for I. So that is the second question. Now going on to the third sub question. We solved until here yesterday. So let us revise this also. Beginning with GIN and ending with GRIN. Okay, beginning with GIN. So if a word is gonna begin with GIN and then it's gonna end with GRIN. Okay, so which means we have GIN, which is already considered. Okay, now GIN is already considered. So GIN in engineering is here, GIN. Okay, so are you all able to hear me? Does everyone have that voice breaking issue? Is my voice clear to everyone? Yeah, okay. Then Rida, maybe it's a network issue from your end. Okay. Yeah, let's continue. So GIN is here and GRIN or RING. You can just rearrange this. There's no problem. Now, leaving this, what are the other alphabets that are remaining? We have E, N, E, E. Okay, so there are 4 other letters which are remaining. So E, N, E, E has to be written in the 4 letters. Out of E, N, E, E, if you see, E is repeated 3 times. Correct? E is repeated 3 times. And how many spaces are we supposed to fill here? We have 1, 2, 3, 4. 4 spaces we have to fill. So for 4 spaces, if we are filling, which means we can fill that 4 spaces in 4 factorial ways. We can fill this 4 spaces in a word in 4 factorial ways. Yes. So that will become your numerator. That is 4 factorial ways. Now, if you see in this 4 words, that is E, N, E, E. If you see this 4 words, E is repeated 3 times. So E is the likely, or E is the same letter which has been repeated. Okay. So that is why this E is taken as 3 factorial here. So what does the formula say to us? The total number of the letters or the permutation that we want to do, divided by the like minded or like things or similar things that we are supposed to consider. If that was x factorial, y factorial, and z factorial. So here in this problem we had four spaces, so 4 factorial is the total permutation we have to find, divided by what is the likeliness or what is the similar kind of alphabets. E is the similar alphabet, so 3 factorial. Now you can solve this. What is 4 factorial? 4 into 3 into 2 into 1. Okay, so you will get 4 3s are 12, 12 2s are 24. Okay, 24. Then divided by 3 factorial is 3 into 2 into 1, 3 2s are 6, 6 1, 6 ones are 6. So 6 4s are 24. Very good. So 6 ones are 6 4s are. So we will be having 4 ways, okay, to arrange this 4 words where E is repeated 3 times. I'll repeat it again. Understand properly. We have 4 ways to arrange the 4 words here where E is repeated 3 times. Understood? Any doubts until here? Okay. Can we go for the next sub question? Okay. Now coming to the next sub question. Hope you remember we have solved such type of questions, but we will be applying them here also. Okay. So here if you see, all the vowels are not together. Okay. So all the vowels are not together. Please understand carefully. All the vowels are not together. That is what they're trying to say. Now, what is that? How do we define all the vowels are not together? So, I can come up with a formula for all the vowels are not together. What is that formula? Total arrangement minus all the vowels are together. If I minus all the vowels are together from the total number of letters that I have or arrangements that I have, then I will get all the vowels are not together. Understood? Understood this formula first of all? Rida, please wait. We will come to that. Okay. Understood until here? Okay. So when I say, now let us take the word. Now in this, can you say me what are all the vowels are there? E is a vowel. G, again I is a vowel. After and again E is a vowel. E is a vowel. R, no. Then I. I is a vowel. So E, I, E, E, I. So this is the vowel that we have. These are the vowels that we have. Apart from this, what are the leftover letters? What are the leftover letters? After E, N, G, I is taken, again N, E is taken, R, I is taken, again N and G. N, G, N, R, N, G. Okay. So these are the leftover consonants. These are consonants and these are vowels that are there. Fine. So if I take a total arrangement, that is this total arrangement, if I take, and then if I subtract this minus, oh sorry, EI, then I will get all the vowels are not together. Okay, now let us see further. Now the total arrangement is 11 letters which are there. So I can arrange 11 letters in 11 factorial ways. Now, since we are dealing with likeliness or permutations of like things, then we should never forget the repetition of the letters. Okay, repetition of the letters we should never forget. So 11 factorial by 3 factorial, 3 factorial, 2 factorial, 2 factorial. So from where did we get this? If you remember, we got this from the first part of the solution. Okay, so first part of the solution, let's go and check once what is there in the first part of the solution for your understanding. Now, if you see here, in the first part of the solution, okay, in the first part of the solution, we had it here. We solved this part. This is the total arrangement or the total permutation. Now, out of this total permutation, if I subtract that vowels are together, then I will be able to get vowels are not together. Okay, so did you understand? Are you able to understand how to find vowels are not together? See, when you read the question, it sounds a little confusing, or you might get stuck. Okay, so you have to break down that question into a formula for you to understand it easily. So total arrangements, 11 factorial by 3 factorial, 3 factorial, 2 factorial, 2 factorial. Okay, so this is total arrangement. So total arrangement, this total arrangement is been solved. Now, let us understand how to solve all vowels are together. Okay, let us understand how to solve all vowels are together. Now, we already identified E, I, E, E, I are the vowels that we have. Now, here they are saying all the vowels are together. Now, when they're talking about together, we can take all the vowels as one unit. Okay, since they're talking about together, we are taking them as one unit. And then whatever is remaining, that N, G, N, R, N, G, okay, the other 6 letters are a separate unit. Okay, so 1 unit of vowels plus 6 units of other consonants will give me totally 7 units. Okay, totally 7 units. Now, before I continue, did you all understand this part? 1 plus 6, 1 unit and 6 units. How about others? Everybody understood? I only got 2 people answering. Okay, 3. Come on, reply if you have understood. Okay. So this is 7. Now, this problem, what we are learning is of like things, correct? Like things. So we should never forget that we have to take the repetitive things in the denominator. Okay, we have to take the repetitive things in the denominator. Now, if you see vowel as 1 unit, this is 1 unit, right? So even if there is any repetition, it will not make any difference because they are considered as one complete unit. But when it comes to the left out consonants, we are supposed to check the repetition here. Now the repetition is N is repeated 3 times, G is repeated 2 times. Okay, R is there only once, so we don't consider that. N is repeated 3 times and G is repeated 2 times. So firstly, in the numerator, we will take 1 unit plus 6 units of the other consonants. So that will become 7 units. So 7 factorial divided by which 2 are repeated? N is repeated 3 times. So 3 factorial. G is repeated 2 times. So 2 factorial. Okay. Now let us solve this. 7 factorial divided by, or you can go like this, 7 into 6 into 5 into 4 into 3 into, okay, 3 factorial and then 3 factorial, 2 factorial. Now I can cancel 3 factorial and 3 factorial. Yes. So 7 into 6 into 5 into 4. How much do you get? 7 into 6 into 5 into 4. 840. So you get 840 divided by 2. Divided by 2, how much do you get? 420. So this is the number of ways if vowels are together. Okay, if vowels are together, then we will be finding it like this. Now we have total arrangements. Okay, now we have total arrangements. Now also we have all vowels are together. Okay, now since we have every information that is required in the formula, let us find out all vowels are not together. Okay, now for each of the vowels that are taken as one unit can be arranged in 5 factorial and 3 factorial. Okay, did you understand until that? Until this 420 ways? Any doubts still here? Fine. Okay, now concentrate. This looks a little complicated, so we are breaking it down. Now here you had E, I, E, E, I. Okay, so this was considered as one unit. And then apart from this, you have N, G, N, R, N, G. Correct? So this is what we solved previously. Now we solved this as total. Fine. Now after solving it as total, now there is vowels inside. There is vowels inside here. So there are 5 vowels which are inside. And out of that 5 vowels, there is a repetitive letter which is E. Correct? So for these vowels, whatever we have taken, there are 5 vowels in total. So these 5 vowels, since they are different alphabets, you see E and I is also there. So these vowels can be arranged in 5 factorial ways. Okay, so these vowels can be arranged in 5 factorial ways. There are 5 vowels and 5 vowels can be arranged in 5 factorial ways. Now out of these 5 vowels, E is repeated 3 times, correct? E, E and E, and then I is repeated 2 times. Understood till here? So first we solve the overall vowels and consonants. Now we will concentrate only on vowels, which is one unit. In that one unit, we have 5 vowels. Now 5 vowels can be arranged in 5 factorial ways. Okay. In that 5 vowels, 3 vowels belong to E and 2 vowels are I. So there is also repetitive or there is also repetition that is done. Understood till here? Guys, are you there? Any doubts? Okay. Now, after getting 5 factorial ways, 5 vowels, 5 factorial ways divided by what is repeated? E is repeated. So, 3 factorial, I is repeated twice, 2 factorial. Okay. So, if you look back to the previous sub question, or you can say we are dealing with the same question here. Now, if you see here, no two, okay, sorry, 1 second. Okay, now all the vowels are not together. We found out the total arrangement. We are still finding all the vowels are together. Okay, so here all the vowels are together is given, and then for the vowels we calculated these two. So totally the arrangement is, hence total words with vowels together is 7 factorial by 3 factorial 2 factorial. From where did I get this? From the last thing here. Okay, so this is overall. Now apart from that overall, you have to multiply that with the arrangement that we got just now. Okay, now coming to the final answer. The final answer is total words with all the vowels not together. Okay, total words with all the vowels not together. This is the total arrangement, 11 factorial by 3 factorial, 3 factorial, 2 factorial, 2 factorial. Okay, so this is the total arrangement minus if vowels are together. This complete expression here is talking about vowels are together. When you had vowels as one unit and we had other 6 consonants and then 5 vowels when they rearrange between themselves. Okay, so this, if you solve this, okay, if you solve this, you will get one answer. Okay, you can solve this and let me know the answer. Will you solve this? Now, before that, did you understand until here? Did you understand this sub question? Any doubts? Everybody understood? See, one thing how you can learn such question is by practice. Okay, I shall give you a similar question today. So I would expect all of you to solve the question and tomorrow we will discuss the question. Okay, so there's one more sub question left. Before that, I want to know if there are any doubts until here. Okay. Now, one more thing is solve this 11 factorial by 3, 2 factorials. Solve this and say me the answer by tomorrow. What is the number of ways where we can find the all vowels are not together? Okay. Can we go to the next sub question, the last sub question? Okay. Now the last sub question is no two vowels are together. So how many vowels we had in the word engineering? How many vowels did we have? E, I, E, E, I. So how many vowels do we have? 5 vowels. Now we have 5 vowels, but they are saying no two vowels should be together, which means I cannot write E and I together, or I cannot write E together, or IE together. I cannot do this. Okay, so no two vowels are together here. So then how do we do the arrangement if no two vowels are together? Now, in such scenario, we will be concentrating on consonants. Now, if you remember, we solved a question of boys and girls standing in a row for a photograph. We had 9 boys, B1, B2, B3, B4, B5, and until B9. Okay, and then we saw, okay, now no two girls should be together. So we had gaps here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had 10 gaps. In that 10 gaps, we were supposed to fill 6 girls. Correct? You remember this problem which we did? If not, go back, check your classwork. Check that problem once again. Now everybody remembers that problem. Now we're going to do this problem in the similar way. Okay. So here we have vowels and remaining are consonants. So they are saying no two vowels should be together. Okay. It's like no two girls should be together. And how many number of boys are there? The consonants, we have 6 consonants. So let us arrange the consonants first. Now how do we arrange the consonants? Let us write down N, G, N, R, N, G. Okay. Now let us find out how much gap is there for us to fill. So here there is 1, here there is 2, 3, 4, 5, 6, 7. Okay. So we have 7 places where we can fill 5 vowels. Okay. So we have 7 options or 7 places where we can fill 5 vowels. Okay. So I can write it as 7P5. Everybody understood till here? Okay. Now, since it is permutation of like things, I should always divide it by the repetitive terms. Correct? I should always divide it by repetitive terms. Now, repetitive in the vowels are E and I. Now, E is repeated how many times? E is repeated how many times here? 3 times. So 3 factorial. And I is repeated 2 times. So 2 factorial. Okay. So this is gonna become our actual answer for no two vowels are together. But there is one more thing that we have to consider. Okay, there is one more thing that we have to consider. Now, first we placed consonants N, G, N, R, N, G. Okay, and then only we tried placing the vowels in the 7 places. Now, these consonants also can change, right? These consonants also can change. It is similar to boys were standing here and girls had 7 other places to stand. Now we solved for girls. Now we have to solve for boys. Now how many boys are there? 1, 2, 3, 4, 5, 6. Okay. So there are 6 boys, which means I can arrange the boys in 6 factorial ways. Agree? Everybody agrees to this? There are 6 boys and I arrange them in 6 factorial ways. Okay. Now, since it is permutation of like things, I should see what is repeated. Now, N is repeated. So, N, this is 1, 2, 3. So, N is repeated 3 times. So, I am taking 3 factorial. So, this N can be arranged in 3 factorial ways. Then apart from that, I have G which is been repeated. So, 1 and 2. G is repeated twice. So, 2 factorial ways. Now, the arrangement for boys is 6 factorial by 3 factorial into 2 factorial. But the arrangement for girls is 7p5 divided by 3 factorial into 2 factorial. Okay, so this is the arrangement for boys and this is the arrangement for girls. Okay, now let us take them together. So total number of words with no two vowels are together. That is, I am talking about the sub question, the final answer. Now when I take both of them, I will consider the arrangement for boys multiplied with the arrangement for girls. So this will be my final total answer. Understood? Everybody understood till here? Any doubts? Okay, so now today we will stop here for today. Okay, but what I want you people to do is rewrite. I will send you this question, so write down this question properly. Okay, solve it twice. At minimum you're supposed to solve it twice and find out the total value. Find out the total value of this and say to me tomorrow what is the number of ways. Let's see how much big number you get. And also find out the total number for this. Solve this and find out the total number. Okay, will you do it? Yes. Okay, so we will discuss the total answer tomorrow once again. Fine. Okay, we shall stop it here and I'll send you one more question to solve so that you can practice that.